Okay, so welcome to the Unit 6, Lesson 4. This lesson will cover graphing rational functions. All right, so our objectives today are to identify and graph the parent functions of a reciprocal function and to identify and apply the transformations to graph rational functions. Okay, so the reciprocal function is basically f of x equals 1 over x, right? So that's just the reciprocal of f of x equals x over 1. So the reciprocal is 1 over x. So these are reciprocal functions when the variable is in the denominator. All right. It's also kind of known as a rational function. So you may see it sometimes called a reciprocal, sometimes a rational, basically the same thing. All right. So another new thing we're going to introduce here is the idea of an asymptote. All right. An asymptote, you're going to see this as a dotted line on the graph that represents a restriction to the function. Okay, and you'll kind of see what that means once we start to graph it. It'll start to make more sense to you. All right, there are two types of asymptotes that we're going to focus on in Algebra 2. Now there are additional types which you'll learn about later, but what we're going to talk about is like a vertical asymptote, which is an x value that makes the denominator equal 0. And is non-removable. Now this non-removable part, we'll talk more about that as we get into some more complicated rational functions, but for right now, it's only an asymptote if you can't remove this restriction. All right? If you can remove it, it'll be something different. But for now, a vertical asymptote is an x value that makes your denominator equal 0. That's the key part we want to focus on here, is this part. All right? The next thing we're going to talk about is a horizontal asymptote. Now, horizontal asymptotes are y values. Y values that the function approaches at its extremes, but it doesn't cross. All right? So this is basically the function's end behavior. It's end behavior. So you'll notice these functions are not going to be going up and down. They're going to kind of be going sideways. The y values will level out, and you'll see that once we start to graph it. But the horizontal asymptote is basically describes the end behavior on both sides. It's a value that the function approaches on the far extremes but never reaches. So let's look here at our parent function. F of x equals 1 over x. All right, and again, like most of the parent functions we discuss, we start off with just some basic points, right? So the basic x values I'm going to pick are -2, -1, -1/2, 0, 1/2, 1, and 2. All right. Now let's kind of look and see what happens if we plug this in, right? If I plug in the -2, this is going to be -1 over 2. If I plug in the -1, it's -1. If I plug in -1/2, well, 1 divided by a half is like 1 times its reciprocal, which is -2, right? If I divide by -1/2, I should get -2. Now, if I plug in 0, I get 1 over 0. Well, that's undefined. It's undefined. Missed an E there. Undefined. And then we can plug in a half. Well, 1 divided by a half is like 1 times the reciprocal, which is 1 times 2. So I get a +2. Plug in a 1, 1 over 1 is 1. And plug in a 2, and I get 1/2. Okay? So let's just start by plotting these points and see what happens. So at -2, I have a negative 1/2. So that's going to be about right there. Negative 1, 1. And then negative 1/2, so about right there, down 2. And we start to see what the graph is doing. And let's think about what happens farther out here, right? As I start to increase, let's say I looked at negative 5. That would be negative 1/5. So way out here at negative 5, it's going to be real close to there. And no matter how far out here to the left, the closer and closer I get to negative infinity, the closer and closer this is going to get to the y-axis, or I'm sorry, to the x-axis, but it'll never reach there. The same as if I was to do like, let's say negative 1/3. That would give me negative 3, right? If it was x over negative 1/3, I would get negative 3. So as I get closer and closer to 0, it'll always be negative. And so my y value will always be negative. And it's going to start to get this form. It's going to look something like that. So my graph is approaching the x-axis but never touching it. And here, as I get closer and closer to 0, it approaches the y-axis but never touches it. Let's look at our other side here. At positive 1/2, I get positive 2. Positive 1, I get positive 1. Positive 2, I get positive 1/2. And again, that same type of relationship, once I'm on the positive side of the x-axis, it'll always be positive. So it's going to be up in this quadrant, and it's going to look something like this. It's just going to come down, but I'll never have a negative y value when I'm in the the positive x side. So there's my graph, right? That's what the graph is going to look like. Now you can start to see what's happening here, right? The domain of this function, as I go left to right, I have all my x values except 0. So it's going to be negative infinity to 0, union 0 to infinity. Because 0 was not part of my domain. At 0, it's undefined. My range, if I'm going bottom up, right, I have an arrow pointing down, so negative infinity. But this left side of the graph, it approaches 0, but it never gets there. And then this one on the upper part of the graph on the right, it's above 0 and then goes up, but it never comes down to 0. So again, this is going to be negative infinity to 0, union 0 to infinity. And this is where we start to see our vertical and horizontal asymptotes, right? Our vertical asymptote, which we are going to require you to graph this in. It's the x value that makes the denominator equal to 0. So, vertical asymptote, x equals 0. The horizontal asymptote, what the graph approaches on the ends, it's approaching 0 here, approaching 0 here, but it's not, so y equals 0. So we want to see both parts of the graph, and we want to see the asymptotes. And as we mentioned, right, this is our end behavior, right? So as x goes to the left, y approaches 0. As x goes to the right, y approaches 0. Okay? So that is the parent function of a reciprocal function. We can talk a little bit now about the types of transformations, and this should look very familiar to you by now, right? Here's the transformations that are possible, and we can talk about what they mean, right? Horizontal shifts, that's going to be x minus h, we'll shift it to the right, h. If it's x plus h, well, that'll be going left, h units. If there's a vertical stretch, then the absolute value of a will be greater than 1. If there's a vertical shift, well, a positive k will move it up k units, and a negative k will move it down k units. Reflections. A reflection will happen whenever a is less than 0, whenever a is negative. And then vertical compression, the absolute value of a, actually we should give it a little more space because it's between 0 is less than absolute value of a, which is less than 1, right? So when the absolute value is between 0 and 1, then it's a compression, right? And we talk about the absolute value because if it was a negative number, that would just be a reflection, right? So focus on the number, not its sign, when we talk about vertical stretches and compressions. And that should all be pretty familiar. So let's just kind of look at some examples on the next page and start to graph this. Hopefully as we start to graph it, you'll start to feel more comfortable with what we're doing. Now, when we graph this, we're going to focus a lot on the vertical asymptotes and the horizontal asymptotes. So if I'm looking here, right, x minus 3, what's the x value that makes the denominator equal 0? Would be 3. So my vertical asymptote will be x equals 3. So I can go over here and put my dotted line there because that's where my vertical asymptote will be. My horizontal asymptote will be my k value. So it's -1. So y equals -1 because it would be y equals 0, but it was shifted down 1, right? So that means there's a horizontal asymptote right there. So now I kind of have recentered my graph, right? And now I can start to talk about my parent function, right? And the way we kind of do this, remember, is we have our values, right? So -2, -1, -1/2, 0, which we don't care about because that's the center right there. And then we have 1/2, 1, and 2. All right, so this was a -1/2, a -1, -2. And this was a 2, a 1, and a 1/2. But again, this is a multiplier. So all this will be multiplied by -2. So this becomes +1, +2, +4, -4, -2, -1. So again, this is my motion, right? From here, from my center, if I go back 2, let's put this in a different color. If I go back 2, I should go up 1. If I go back 1, I should go up 2. And if I go back 1/2, I should go up 4. 1, 2, 3, 4. So these aren't points, right? This is delta x, delta y, right? This is motion. This is movement. So I'm here. I'm at these points. So I know that my graph is going to look like this. And again, from my center points, from where my two asymptotes connect, if I move over 1/2, I should go down 4. And there's my 4. I move over a whole 1, I should go down 2. Move over 2, I should go down 1. And there's the second half of my graph. Now, don't get too tripped up with all of these points, right? What we really care about is being able to get at least a couple on each side. So if you kind of don't do the fractional ones, that'll be fine. Just trying to get 2 good points on each side of the asymptotes, and we'll be fine. So let's kind of analyze it more. We can talk about our domain, right? Our domain would be negative infinity to 3, union 3 to infinity. Our range would be negative infinity to negative 1 to infinity. So you should be able to see where our domain and range is coming from. It's coming from our asymptotes, right? The vertical determines the domain. The horizontal determines the range. Your horizontal is also determining your end behavior, -1 and -1. So if I was to analyze, you should be able to answer these questions really before you even graph the function. And if you can, then that tells you a lot about what you understand and what you are having trouble with. Okay, so by looking here, I should be able to tell that my vertical asymptote is equal to -3. My horizontal asymptote is equal to y equals -2. I should be able to tell you my domain is negative infinity to -3, union -3 to infinity. My range is negative infinity to -2, union -2 to infinity. And then you should also be able to tell me the end behavior, which is -2, -2. All right, you should be able to do all of that just from the equation. And now when we're talking about graphing, what we would expect you to be able to do is to be able to put in your asymptote here at -3 and here at -2. It's not stretched or compressed, so you should be able to do -2, 1/2. Sorry, that would be -2, -1/2, -1, -1, and -1/2, -2. So you should be able to give us these basic points and get that into the correct quadrant. So that's basically what we're looking for here, right? If you're wondering how I got those, again, -2, -1, -1/2, 1/2, 1, and 2. So -1/2, -1, -2, 2, 1, 1/2. And there's no multiplier. So delta x, delta y. Again, these are not points. These are movements, moving from where your intercepts, where your vertical and horizontal asymptotes cross each other. All right, so try the next 2. Graph these next 2 and answer these questions, and then I'll come back and show you the answers. But first, pause the video and try this. You all should be trying these questions on your own and not just copying down what we're doing. So try these, and then I'll show you the answers. So pause the video. Okay, so here are our 2 graphs. So you should at least, at minimal, you should have the asymptotes correct, and you should have the general direction and position of these graphs. The red lines should be approximately the right place, and the purple line should be correct as well. All right. And then here's the answers to the questions. Hopefully you got all of those correct as well. And that is lesson 4, basic graphing of reciprocal and rational functions, with a little bit of figuring out domain range with an introduction to vertical and horizontal asymptotes. So let us know if you have any questions, and be ready to do some graphing next class, as well as studying for the quiz, which is on lessons 1, 2, and 3. All right, have a good night.